This question deals with the acceleration of a particle. A particle moves on the x-axis in such a way that its position at time t is given by s of t is equal to 8t to the third minus 18t squared minus t to the fourth. When is the acceleration of the particle positive? And we have a multiple choice question here. All right, so you need to understand the position function, the velocity function, and the acceleration function and how they are related. So we're going to start with that position function. Okay, so let's just label it as the position function. It is s of t. So we'll go ahead and write it down. 8t to the third minus 18t squared minus t to the fourth. All right, now if I want to find the velocity function is the derivative of the position function. So s prime of t. All right, I could also say it's v of t, because we know that you find the velocity by taking the derivative of the position function. So we'll run just a straight power rule here. We'll have a 24t squared, and then minus a 36t, and then minus a 4t to the third. All right, now the relationship between velocity and acceleration is, again, we take the derivative. We're taking the second derivative of the position function. We're taking the first derivative of the velocity function. That gives us the acceleration function. So let's label it acceleration. All right, it is the second derivative of the position function. It is the first derivative of the velocity function, but then we can also call it a of t being the acceleration function. So again, taking the derivative right there, we're going to have a 48t, and then minus a 36, and then minus a 12t squared. All right, now I am going to take this, rewrite it so that it looks like a quadratic, and set it equal to 0. So I'm going to set it equal to 0. I'm going to label it as a negative 12t squared, and then a plus 48t, all right, and then a minus 36. All right, now I really don't want to factor something with a negative coefficient here, so we could think of moving everything to the left, and then that's going to change the signs of everything. So if I do that, I'm going to have a 12t squared minus a 48t, and then plus a 36 now equals 0 on my right-hand side. Let's factor out greatest common factor of 12. That's going to give me a t squared minus a 4t plus a 3. All right, if I set everything equal to 0 after I factor this, I can set this equal to 0, which gives me a false statement. Factoring this and setting these equal to 0, I'm going to have a t and a t here. I need a positive 3, but negative in the middle, so I'll have two negatives, minus 1 minus 3. Setting these equal to 0, I get t equal 1, and I get t equal 3. So this tells me that my particle, the acceleration of my particle, is going to be positive in between the time of 1 and 3, and that makes D the correct answer. So a pretty straightforward question, as long as you know the relationship between your position function, your velocity function, and your acceleration function. Definitely something that you would encounter in your beginning 1 calc class. Definitely thanks for watching. If the videos are helping, please share with your friends so they can benefit too. And don't forget to subscribe to the channel. Thanks.